All right, welcome everybody. My name is Ryan Jones. I'm one of the applications engineers here at Unitronics. I'm joined by Michael Poles and Dan Logie. If you have any questions during the presentation, feel free to send them a question either in the question window or the chat window. They'll respond to you as quickly as they can. Today we're going to be doing three quick topics: advanced function blocks. We're going to be going over the filter function block, the math formula function block, as well as the drum sequencer. We're going to start right away with the filter function block. So this is under in VisiLogic, underneath the function block or FBs tab. Go down, you'll see filter. Basically, what it allows us to do is to take a average of any given value. So rather than just, if you imagine an analog input coming in, we don't just take the real-time reading. We actually take a reading over time and then take the average of it to get a more accurate result. There's basically only two parts to using the filter function block. The first is the configuration. Of course, we want to put this on SB2. That's our power-up condition. It's going to run once when the controller first turns on, and then it's never going to run again. It's going to ask you for three pieces of information. The first is if you want to do a dynamic average or a order-weighted average. What that means is for a dynamic average, each value is going to have the same weight in the end to the result. Whereas the order-weighted, the newest values have more significant weight to them than the oldest values. So if you imagine a FIFO system, the value that's about to be erased is not as significant to the average as the newest one. Next, it's going to ask you for how many operands you want to collect when we're doing this average. You can select from 4 to 16. In this example here, I've selected 8. And then how many values do you want to discard. This is for high and low. So if I select 2 here, it's going to discard the 2 lowest values and the 2 highest. It's a great way to remove any outliers or erroneous data. If we have a spike on an analog input, we don't want to affect our average, so we're just going to remove it. So when we run the filter, we're going to start collecting these values, all from the same operand. So every time the filter calculation block is run, we add a new value to the vector. This is an internal vector. You don't have to assign this anywhere. This is all in the OS. So again, every time we hit the filter calc, we're going to add a new value in a FIFO. So everything just moves down, and eventually when it reaches the end, it drops out. So here we've collected 8 values of ML0. And since we have said to discard the 2 highest and the 2 lowest, VisiLogic or the controller is going to go in, finds the 2 lowest, drops them out, finds the 2 highest, drops those out, takes the remainder, this 30, 60, 50, 40, and takes the average of that. So basically 30 plus 60 plus 50 plus 40 divided by 4. This feature is also in the hardware configuration. When you set up any analog input, except for a 10-bit analog input, you'll be able to select a filter and a strength of either low, medium, or high. It's the same concept. A low filter will just take 2 values and take the average of those. The medium filter will take in 4 values, drop the highest and the lowest, and then take an average of the remaining 2. And the high strength filter is exactly what you see here. We take in 8 values, drop 2 highest and 2 lowest, and take an average of the remaining 4. So I'll show you real quick what it looks like in VisiLogic. So here's our configuration block. which again is just right down here under function blocks, config. We can give it a name. We select which type of average. I just did a regular dynamic average. How many values we want to collect, and then how many we want to discard. Here's the calc. So every time this function block gets run, it pulls another reading off of the linked operand and then outputs the filtered value. I have this right on the rail, so I'm always going to have a filtered value in ML4. However, if I wanted, I could have put this on a positive transition or some other condition to only, add to the filter on some other mechanism. So pretty simple. Actually, and one more thing I want to show you here is the hardware configuration. So this is the built-in filter. You'll see here I have a type J thermocouple, and there's an option for a filter. You can say low, medium, or high. The filter function block is if you want to create your own custom filter or you want to filter a value that's outside of your hardware configuration. All right, next I want to show you the formula function block. It makes doing advanced math functions a lot easier and a lot simpler. Instead of having a long winding net with a whole bunch of different function blocks, we can actually simplify things into one singular formula. It's a lot easier to create. It's a lot easier to follow as well. If you're looking at someone else's or looking at a program later or from someone else, it's a lot easier to understand because it's written the way you would expect it to be rather than in a long winding series of individual function blocks. You can find this one under Math, Formula. That's what the window is going to look like when you first drop it down. You'll see here it's just written in relatively plain English. I made the Pythagorean theorem here, basically just taking the square root of a squared plus b squared to find the length of a hypotenuse. And I wrote this just by typing right in the keyboard. So I can do a squared parentheses plus b. The lettering at this point isn't really important. You can just use any values. I could have used x and y instead of a and b. You're just basically laying down the framework of what what's going to happen next. To add the square root here, if you see over down here, there's the select function. This is where we can add any of the more advanced math functions. So square root, absolute value, exponent, etc. It does follow, the normal order of operations. So be sure to use parentheses to make sure things get operated in the order you like. After you click OK, you'll see your parameters on the left here, and then I'll ask you where you want to link them. So for my A and B values in my equation, I've linked them to MI19 and MI20, which I've created in my program as sides of a triangle. You'll see both forms up here, both the equation form, square root of a squared plus b squared, as well as the actual results. So what the controller is actually going to do. It's going to take the square root of MI19 squared plus MI20 squared. And of course, lastly, we just need to store the results. And I have that linked here to MI21, my side C. So one clean little function block, very easy to read. If we go online for a second. So here's my triangle. I can change some of these values. And you see the C value updates automatically. Definitely a big time saver. Another quick time saver that we have, if you're doing just a lot of addition or multiplication, basically doing the same math function repetitively. Let's say you're trying to take an average, and so you're trying to add 5 MIs together. Rather than doing 5 separate add function blocks, we do have these add X, let's call them function blocks, where we can add 3 values, 4 values, 5 values, etc. It's also available for multiplication, division, and subtraction. Just makes it a little bit easier, more streamlined, rather than having to do them individually. Any questions on any of the filter or the formula function block so far? Okay. So lastly, one little more meat to it. This is the drum sequencer. It simulates a mechanical drum sequence by toggling a series of outputs in a particular order infinitely. The easiest way to visualize it is perhaps a music box. You know, we have this drum that's rotating with pegs, and every time the peg comes up, it hits the chime or the note. Same principle here. We can trigger a output or a bit. So I'll show you a sample program I've created using the drum. All right, you'll see here I have these 5 lights kind of trailing from left to right. They're just run by bits, so the drum can control anything that a bit value has. You can use that bit to run a subroutine. You can fire an output, you know, turn on a light, something on the HMI, you know, whatever you like. I could have used just sequential timers to create the same program, but wouldn't have been as easy. As well, it wouldn't be as easy to edit after the fact. I'd kind of have to go back and dissect or disassemble my code and reassemble it, whereas with the drum, I can easily just go into the different steps and change the time, make it longer, change the output, etc. So I'll show you how I did this. All these are going to be under function blocks, drum sequencer. First thing we're going to need is the configuration. Okay, window looks like this. And here is our virtual drum. It is a drum, you know, it's a cylindrical object, so where the drum ends is where it begins. So once we reach the last step, we come back up to the first. Each step is going to have a duration. Just edit that just right here. If I want to make the first step 2 seconds rather than 1 second, I can just add it there. I can change where the drum starts. Doesn't necessarily have to start at step 1. I can have it start at step 5. I can add and remove steps. This is the append step button. As well as remove. These are my LEDs. So I have 5 binary images on my HMI linked to these 5 bits, MB10 through MB14. If I want it to be on during step 1, I just give it a check. And if I want it to be off, I just uncheck it. Similar to adding steps, you can add outputs. And then add what you want, how you want it to function. All fairly straightforward. You can change the name of the drum if you have multiple drums. You want to keep them organized better. You can give them a better title. But just for this example, we have drum sample. You have a operand down here called the current step index. That's just going to be an MI. It's going to tell you what step the drum is currently on. And lastly, the last thing I want to show you in this window is I can give a step a value of 0. What will happen if you give it a value of 0, the drum will continue to run until it reaches that step, and then it's going to stop. Normally, if all these have a value, it's going to keep on going. Once it gets to the last step, it's going to come back up to the first. If I have any step that has a 0 value, it's going to stop and pause at that step and wait for me to tell it to advance or reset or give it some other condition. It'll stop whenever it reaches a 0 step. All right, the next thing you need, now that we've set up our steps and our outputs, we need to run the drum. That's using the scan function block. Whenever this scan function block is receiving power from the rail, the drum will run. So I just have a simple bit here that says run stop on my HMI that'll begin the drum or stop it. If you ever want to reset the drum to your starting position, we have a function for that. Go to Start Step. If you remember, the Start Step is just a checkbox here in the configuration. Doesn't necessarily have to be the first step. And whenever we trigger this function block, we'll go to that step. If you want to go to a particular step, what you do is you change the operand we have selected for the step index. And then we trigger a go-to step. Note that you can't just change the MI linked to the current step index. If you do, it's not actually going to take effect. You need to change it and then activate the go-to step function block. Just changing it is not enough. On a similar note, we also have next step. Basically just advances forward. If we had all of our steps with 0 time, we could just use the next step function block to go through them one by one. Whatever step you're on, just immediately goes to the next one. So let's take a look at that again. All right, so again, I have this bit up here. This is linked to my scan. You'll see it's going through the steps. See the current step index incrementing. And then it stops when it reaches that 0 value that I had in step 10. Now I have a couple choices here. I can reset it by going to the start index. I can go to the next step, or I can enter a new step to go to. I'm going to have it go to step 5. You'll see it resumes at step 5. If you do have a process that is supposed to be running continually, and you want it to resume wherever it leaves off whenever you reset the machine, so normally if you reset the PLC and it starts the drum again, it's going to want to go to the start step. If you want it to resume wherever it left off, what you would do is this, on power up, as soon as you turn the controller, you would use the go-to step. So just store the current step that you're on, the controller powers off, power it back on, store that value into the go-to step, and we'll resume right where we left off. So, does anybody have any questions on drum? All three are really straightforward. The filter, the formula, and the drum. But they're really great time savers, as well as organizational tools. Like I said, most of them are not necessary. We can do without them. We could do a series of timers for the drum. I could have used my own math functions to create a filter. Or I could have, had a long subroutine to do the formula. But it's just a lot more work, and it's also not as clean. It's a little more confusing to look at, especially if it's not the program you wrote. So it makes it a lot easier to read, a lot simpler to edit, and really just a better way to do simple tasks. Cool. So if anyone doesn't have any questions, again, I want to thank everyone for coming. I know it's kind of a quick one today, but we hope to be doing more webinars coming up once or twice a month with little tricks and tips like this. As well as if you have any requests for a future webinar, please let us know. Just send us an email, support@unitronics.com. With an idea that you'd like to see or a topic that you find confusing. We'd love to showcase it for you. Again, my name is Ryan Jones. Thank you all for coming, and have a great day.